Okay, so for question 12, it's still referring to this context of pushing a friend in a smooth frictional surface. And in question 11 we figured out how long the cell would have to move for it to change its velocity from 1.2 meters per second to 2.3 meters per second. So in this particular case, in question 12, we're trying to figure out by how much distance will the stud move during that push. So in this particular case, we're trying to figure out delta x. This is related to constant acceleration kinematics, but the acceleration will be determined using Newton's second law. So if we want to figure out how far the object moved, we could consider what is the average speed over this time interval. That would be one way to do it, and maybe we can solve it in both ways. So I'll start with maybe just considering the acceleration piece. So Vf squared equals Vi squared plus 2a delta x. So the delta x would be equal to Vf squared minus Vi squared, all divided by 2a. In this case, that would be the 2.3 meters per second all to be squared minus the 1.2 meters per second all to be squared, divided by 2 times the acceleration. But the acceleration would have to be determined from the net force divided by the mass from the previous question. So that would be divided by the net force. In the previous question, what we found was 25.4 newtons, and we divided by the total mass. So the delta x works out to be 5.3 meters if we use this particular method. So that's incorporating what the known final velocity, the known initial velocity, but using the F net and m to solve for the a, and then using the constant acceleration kinematic equation to determine the value of delta x. But you could also figure out that delta x is equal to V average times delta t. And this is when an object moves with constant acceleration, the average velocity will be half the sum of the initial plus the final. So you can write this, if assuming the acceleration is constant, you can write V average as half of Vf plus Vi, and the time would have to be determined from the previous question, which was 3 seconds as noted here. So this delta x will be 1/2 of 2.3 meters per second plus the 1.2 meters per second times the 3-second interval, and this should also give you 5.3 meters, which was, these choices are noted, these choices are not correct, but on the exam it was noted that choice A was 5.3 meters.